Hello everyone. Today we are going to discuss a problem on AC circuits of an RL circuit in which the resistance and the inductance are in series. So we have a question here. An RL series circuit is connected to an AC supply of 230 volt RMS, frequency 50 Hz, and the resistance of the circuit is 20 ohm and the inductance is 0.1 Henry. So what we need to calculate is first the inductive reactance of the circuit, then the impedance of the circuit, the RMS current flowing through the circuit, determine the power factor of the circuit, find the power consumed in the circuit, and then the phase angle. So let's move to the step-by-step solution of this numerical. Before that, we get the circuit diagram. As we can see here, the voltage shown is 230 volts. The current passes through here. It's an AC source, and the resistance is 20 ohm, and the inductor, which is of 0.1. Now we move to the step-by-step solution. So to first calculate the inductive reactance, we know the formula for inductive reactance, which is XL is equals to 2 pi FL. We just plug in the values as we have, and then we get inductive reactance as 31.4 ohm. Now we calculate impedance. We know the formula of impedance as Z is equals to root over of resistance squared plus inductive reactance squared. We just plug in the values, and then we get the answer as 37.23 ohm. This is the circuit diagram, and this is the impedance triangle. In an inductive circuit, that is an RL circuit, the current lags the voltage by a phase angle of phi. Now we calculate the current. We know that I is equals to voltage by impedance. We just plug in the values, and then we get I is equals to 6.18 ampere. Now we calculate the power factor. The formula for power factor is cos phi is equals to R by Z, that is the resistance by the impedance. Now we just plug in the values, and we get 0.54 is equals to lagging, as I said earlier that current lags voltage. That's why it is said in an inductive circuit. From the impedance triangle, we get a clearer view of the phi. Here cos phi, if we try to represent, then we have that R as the base and Z as the hypotenuse. So cos phi is equals to base by hypotenuse, and then we get 0.54. Now we are going to calculate the power consumed by both the resistance as well as the inductor. So we know power consumed is equals to VI cos phi. We just plug in the values and get the answer. Phase angle, we know cos alpha is equals to cos phi, is equals to 0.54. Therefore phi is equals to cos inverse 0.54, and we get 57.32 degrees. That is, the angle between the resistance and the impedance is 57.32 degrees. You can get it clear from this impedance triangle. That is, the angle between the resistance and the impedance is 57.32 degrees. Thank you so much.